When we're investigating limits, we have different approaches. One approach is we can use a graph to see if we can figure out the limit. For example, think about this function right here, f of x equals x squared times x minus 2 over x minus 2. If I wanted to figure out what the limit was as x approaches 2, I might just look at the graph, right? I go down here to 2, and I go up. And even though there's a hole there in the graph, we really can't see it. And, I can click on it. You can see, the function is undefined there. However, we can tell what the limit is. The limit is going to be this y value here, over here, the 4. So we can approach the finding limits graphically this way. But there are other ways. A way I want to look at now is numerically. So let me, what I've got here is I've got this point a f of a. Let me turn this on and turn on the label. And I've got down here b f of b. Let me turn that on, turn on the label. And you can see that I've got, this is a point on that function 3, 9, and this is a point on that function 1, 1. And I've got sliders over here. Now, what I want to do is I want to think about, let me just turn this one off real quick. And let's look at approaching x equals 2 from the left. In other words, let's suppose that I increment b by tenths. See? So here's x equals 1, x equals 1.1, x equals 1.2, and so forth. And what we do is we're trying to figure out, okay, what y value is being closed in as we approach from the left, as we increment by tenths in this case. We can increment by hundredths or thousands, but just by tenths here. Look what happens. We notice we've got a y value of 1.1, 1.44, 1.69, and so forth. And you can see that, this x is getting closer and closer to 2, and we can kind of pay attention to the trend here. Well, what is y getting closer and closer to? See that? Looks like, so at 1.9, we're at 3.61. Now, I could go the other way. I could come from above. Let me turn this one on. See? Now I'm at 3.9, and let me go the other way, decreasing by tenths. See? See? We pay attention to the y's. What's happening here? The y is decreasing, right? 6.76, 6.25, 5.76. And we just take note, okay, as x is getting closer and closer to 2, what is the y getting closer and closer to? And I went ahead and put in y equals 4, little horizontal line here so that we could see. But it looks like, just looking at these numbers, we're closing in on 4. See, we're above it here, 4.41. We're below it here, 3.61. And it looks like we're closing in on that number 4. Now, we could change the step here. I could make it 0.01, right? And look at that one. Then you can see you're getting even closer. So let me come up here, 0.01. And you can see, I'm really getting close to 4. And I could do the same thing up here, 0.01. And I could get even closer. See? Get even closer to 4. We're at 4.285 above and 3.92 from below. So when we talk about evaluating a limit numerically, or from a table, we might talk about a table, this is what we're talking about. We're talking about, okay, let's put in little incremental values, a little smaller above the x value that x is approaching and below, and see if we can determine what the function is getting close to as x gets closer and closer to the value. In this case, as x gets closer and closer to 2, incrementing it by very small amounts, we're kind of paying attention to the trend here and see if it looks like there's a pattern. Where is this thing headed? Well, look, 7.29, and we just move this thing down and we can say, it's getting closer and closer to 4. The same from below, okay? And sometimes we might want to make a table out of that. Now that problem may look like this if we weren't given the graph, if we were just asked, okay, we're given a function here, that same function, and we're asked to numerically see if we can conjecture, look at some numerical values and see if we can conjecture about this limit as x goes to 2. So how that game is played, usually you're given some x values. See, I have some x values here. X is 1, 1.1, 1.2, 1.3, and so forth. And then I have some, and that's below x equals 2. See, it's building up to 2. And then I have some values above 2 winding down to 2. Okay, see, like this. Okay, and so you see, okay, when x is 1, we get 1.21. When x is 1.1, when x is 1.1, we get 1.21. When x is 1.2, we get 1.44, and so forth, all the way up here to 1.9, and we get 3.61. Well, if we come the other way, we can see the y's are winding down. And here at 2.1, we have a y value of 4.41. When we were at 1.9 for the x value, we had 3.61. So it looks like, I mean, we're not incrementing the x's by very much. It's just 0.1. Well, we're incrementing them by a lot. Maybe if we wanted to get a better conjecture, we would increment by hundredths or thousandths. The point is, you can see that, yeah, it looks like this one is heading toward maybe 4, and this one's heading toward 4. I mean, 4 seems like a reasonable conjecture. But I use I use tenths for the x increments just to make it a little bit simpler to see the process. If we wanted to actually conjecture about the limit, we might want to choose increments of 1,000th, or something like that. But that's the way we can conjecture about these limits numerically. And we would say, okay, I think that limit is 4. So that's what we would do.